Hello everybody and welcome back to my channel. Today I have another amplifier, but not built by Rockford Fosgate. I have a Japanese amplifier from Alpine. It's a model 3539 and the ratings are 150 watts per channel into a 4 ohm load of continuous power. First I had to fix this amp, but luckily only two filter capacitors were damaged and some traces and contacts were bad. I am really impressed about the build quality. Take a look at the transformer. The transformer is heat protected. There's a temperature sensor on the transformer. Then the transformer is shielded. If you flip the main board, you can see there's a copper shield around the transformer. And on the back side of the main board there are lots of face mounted devices, SMD technology. I've been told that this amplifier is from the late 80s, maybe the early 90s. I don't know. If you know more about it, please let me know in the comments. The amp features a gain part for each channel, and what I really like about the amplifier is that I can use a switch and you can match both channels to a 0.5 volt of input sensitivity. The downside is that the amplifier doesn't have any crossover filters. This amp is also subscriber supported. Thank you very much for sending this amp to me. The Alpine is connected to the dummy load. Let's zoom to the scope and start the dyno. Continuous power test, 4 ohms, both channels driven. Clipping, reducing gain. Take away the input power, and it doesn't look too clean. I will reduce the gain a little more. That looks better, I think. Let's take this. So what do we have here? We have a maximum voltage. Scope says 80.4 volts. I go to the top of the positive waveform and I can confirm 80.4 volts. That's impressive. Mono 8 ohms. The amplifier delivers 414 watts. That's 207 watts into a 4 ohm load of continuous power, both channels driven. Let's have a look at the amplifier's efficiency. How many amps does it pull out of the power supply? And that's, let's say 60 amps. The amplifier has an efficiency of around 50%. Continuous power test, but this time with 50 Hz. Clipping. Take this, stop signal input. We have with 50 Hz a little less. We have around 79, let's say 78.6 volts. The amplifier delivers impressive 396 watts, mono 8 ohms. That means 198 watts per channel into a 4 ohm load of continuous power with 50 Hz. Dynamic power test, 1 kHz, 20 cycles. I catch one burst. Free of clipping in the first cycles. I go to the last one. Also free of clipping. And the scope says we have a maximum voltage of 81.6 volts. And yes, I can confirm 81.6 volts. With 1 kHz dynamic burst, I have a dynamic power of 426 watts into an 8 ohm load mono, and that means we have 213 watts of dynamic power per channel, both channels driven of course, and the efficiency is 51.8%. 1 kHz dynamic power test, but with 8 cycles. Catch the first burst and it's okay, we have no clipping here. I go to the last one and check it out. It's also okay. And the scope says we have a maximum voltage of 84 volts. Let's have a look at the top. We have 84 volts, and with 8 cycles the amplifier delivers 452 watts, mono 8 ohms. That means 226 watts into a 4 ohm load per channel, both channels driven. With just 1 cycle for absolute short-term power, the amplifier delivers the same output power like the test with 8 cycles. So I switched to 2 ohms per channel test. I will not do a continuous power test with 2 ohms. I will just do dynamic power test. Dynamic power test, 20 cycles, 2 ohms per channel. And of course all cycles at the same voltage level. So we have 67.2 volts. Dynamically we have 579 watts, mono 4 ohms and 289.5 watts into a 2 ohm load per channel, both channels driven. Dynamic burst power test with 8 cycles. All cycles at the same voltage level. I go also to the last cycle. And it looks okay. Yeah, 70.8 volts, 642 watts. That's 321 watts per channel into a 2 ohm load, both channels driven. Dynamic power with just 1 cycle, that means peak power for 1 millisecond. It says 80.4 in this case. We take 80.4 volts. We have a nice increase in short burst power. We have 828 watts, mono 4 ohms. That means 414 watts into a 2 ohm load per channel, both channels driven. Dynamic power test, mono 2 ohms, that means 1 ohm per channel, both channels driven. I am going to catch one. And I go straight to the last cycle. It gets a little bit distorted here. But cycles are at the same voltage level. That's okay. Scope says 50.4 volts, 635 watts. That means 317 watts of dynamic power, 20 cycles into a 1 ohm load per channel, both channels driven. 8 cycles. Catch one. No clipping here. I jump to the last cycle. Scope says maximum 55.2 volts. Let's double check it. Yeah, that's realistic. And with just 8 cycles we have 761 watts into a 2 ohm monoload. That means around 380 watts of dynamic power into a 1 ohm load per channel, both channels driven. Now let's check out what the amplifier is able to put out into a 1 ohm load per channel, both channels driven for just 1 millisecond. And we have catched 1 cycle. Scope says maximum voltage 70.8 volts. Yeah, that's true. Let's calculate with 70.8 volts. We have also an amazing increase of 1 cycle burst power. Mono 2 ohms, the amplifier puts out 1253 watts and 626.5 watts into a 1 ohm load per channel, both channels driven for just 1 millisecond. So I believe if some guys say that this amplifier sounds great, it has great dynamics. amplifier performed well in the tests and had a lot of dynamic headroom, and I was really impressed. It's a small amplifier with some serious power. If you like this video, you can make me happy by leaving a thumb or subscribe to my channel, and if you're already subscribed, don't forget to hit the bell button. See you next time, and thank you very much for watching. Bye bye.